I chose prompt B, which looks into different types of point mutations. First, we look at the coding strand of DNA that we are given. The coding strand is the opposite of the template strand, so the coding strand and the mRNA that is made during transcription are the same, except we have to change the T's in the DNA to U's in the mRNA. I designated this here by highlighting the T's and U's, but we can see that everything else remains the same. Translation is the process of reading the mRNA and turning it into its complementary amino acid, which can be done using the coding dictionary. The mRNA of the original strand can now be translated. AUG stands for methionine, UGG codes for tryptophan, AAC codes for asparagine, GCU codes for alanine, UGC codes for cysteine, and UGA is the stop codon. So this is our normal amino acid sequence for our given mRNA. A point mutation is a change in a single base. The mutation is a transition if the base is changed from a purine to a purine or from a pyrimidine to a pyrimidine. Conversely, the mutation is a transversion if the base is changed from a purine to a pyrimidine or vice versa. A missense mutation is a mutation that will change the original codon so that it codes for a different amino acid. Here we are going to change AAC to AAA. As we go through a translation for this mutant strand, we can see that AAA codes for lysine, which is different from our original amino acid sequence, but the rest of the sequence remains the same. This is a transversion because we went from a pyrimidine to a purine. This missense mutation changed a single amino acid in our sequence. A nonsense mutation changes the codon into a stop codon. Here we are changing UGC to UGA. Translation is the same as the original until we reach our mutated codon, which now codes for a stop codon. This nonsense mutation will cause a premature stop codon to occur. This is a transversion because we went from a pyrimidine to a purine. Silent mutations do not change the amino acid sequence because the normal codon and mutated codon code for the same amino acid. Here we are changing GCU to GCC, which both code for alanine. As we go through translation, we get the same amino acid sequence as the normal sequence. This is a transition because we went from a pyrimidine to a pyrimidine. Read-through mutations occur in the stop codon and result in changing to a normal codon. Here we have a mutation in our stop codon that changes UGA into UCA. Translation is normal until we reach this mutation. UCA codes for serine, which does not signal translation to halt, so the rest of the sequence is also translated. This is a transversion because we went from a purine to a pyrimidine. Changing the stop codon allows for the rest of the mRNA to be read through and translated. Point mutations can have major effects on the amino acid sequence, but they also may not, such as in the case of a silent mutation. It is important to know that mutations are not always bad and can happen very often, but we can study them to find out their implications.